Hello, everyone. The cat is currently taking a nap in the cat tree behind my desk, which you actually can't see just yet. So once I start talking, she may get up. There's a chance she'll appear. We'll see. Hopefully you should be able to see my slides. If I can get comfort. Okay, good on that. All right. Welcome to Modern Infrastructure as Code with Ansible. Thank you all for attending. I am really excited to talk about Ansible because it has been a big part of my day job for several years now, as I have been learning to automate server deployments and automate application deployments and enable pipelines and just enable automation across a business. This is going to be a very quick talk because there's a lot to cover. First, to give you a little bit of an idea of who I am. My name is Joe Ferguson. I'm a senior full stack dev at a company called Precedence. I'm an open source geek. I am also a big fan of the Windows subsystem for Linux, and I also enjoy racing, hockey, and soccer. You can find me on Twitter. Please ask me questions on Twitter, ask them in chat. I'm happy to talk about any of this stuff. I love nerding out about automation and different DevOps tooling. For further reading, I always like to start a talk with where could I go after this talk? Because I'm definitely not going to teach you Ansible today. So how to get more information, or the best learning tutorial if you learn well from books, is going to be Ansible for DevOps by a fantastic person from the PHP community named Jeff Gerling. If you have ever looked into Raspberry Pi, you may have heard Jeff. He has a fantastic YouTube channel, and I'm sorry, but I have to show you this cat who has appeared, and that's the one token cat appearance, sorry, for any of the dog people out there. Ansible for DevOps is one of the books that became a really big resource for me when I was learning Ansible, so I am always up for recommending it. Jeff also keeps this up to date, so you can buy this book and it's on LeanPub, or you can buy it on whatever your favorite platform is. It's a fantastic resource for learning about Ansible. Now, what is Ansible? Ansible is a free software platform for configuring other computers. It was initially released in 2012. It's been around a really long time. There was a company formed originally around to offer commercial support for Ansible called Ansible Works, later renamed to Ansible and ultimately acquired by Red Hat in 2015. Ansible is written in Python, supports Linux systems as long as you're on Python 2.4 or higher, and it also supports Windows systems as long as you're running PowerShell 3 or newer, which would be typically most of your newer end systems. Some of the design goals of Ansible are really kind of what makes it foundationally a great system for automation. The design goals are be minimal in nature by not adding to system dependencies to be able to work. There's not a client for Ansible. By not deploying an agent and using OpenSSH instead, Ansible gets to fall back onto the security provided by OpenSSH and not have to inherently worry about system security of its own agent because the agent doesn't exist. The other foundation or design goal is the ability to run playbooks over and over without breaking anything or inadvertently affecting the systems in a negative way. This is called idempotence. And it is essentially, you can run the same command over and over, and it won't throw an error, and it will always apply the desired state. The other last design goal of Ansible is it's easy to read because everything's based in YAML. Well, most things are based in YAML. And I can already hear some of you groaning now that you hate YAML. I agree with you. Some days I feel like I'm just a YAML developer and all I'm doing is writing in YAML. But don't worry, there's light at the end of the tunnel, because if you hate YAML because of the white space, turn on your IDE white space character show display, and that should help you out tremendously with Ansible. At least YAML, sorry. So how do you get Ansible? Well, I told you it was a Python package, so you just pip install Ansible. And now I have a lot of angry PHP developers saying, excuse me, sir, this is a PHP conference. We are PHP developers. We don't do this pip stuff. And I assure you, pip is not as complicated as it sounds. Think of pip as a much, much worse composer. In Python land, we do not have the great, amazing awesomeness that is Composer. We have much more older and antiquated tooling that has to support many more different formats. So Python package management isn't fun. But You use Python just a little bit here. I'm not going to overload you too much with Python because what I want to show you is what Ansible can do, not necessarily how it does it. I want you to get just enough out of this to go in and explore Ansible and figure out and start thinking about how you can automate really boring stuff in your own workflow. So the Ansible concepts are essentially how things work from top to down, or top down, bottom up, however you want to think about the Ansible stack. A module, which is where we start, it would be an apt or would be a module which is written in Python that you use to accomplish a task. It's a work unit. There are several modules in essentially what's called the Ansible standard base or the standard library. So there's a lot of modules that you get out of the box. If you use a host such as DigitalOcean or someone else, there may be an Ansible module. There is specifically for DigitalOcean. There may be a module that allows you to do common tasks easily without having to write those playbooks or tasks yourself. So modules are a collection of tasks that do something to work together, whether that's to deploy an application, deploy a Docker image, or even just update a Git target or install packages. Inventory configuration is the second concept. This is a declaration of target systems to perform tasks upon. You have a control node. When you're just starting out, the control node is essentially your machine. It's the node that you are running all of the Ansible tasks from, or the Ansible playbooks from. You'll obviously need SSH access through the firewalls to access these systems. Playbooks are the complete set of roles, which are a group of modules to perform a larger task. So you take a playbook, which is a large top end. A playbook is made up of inventory configurations, modules, and actions. So all of these different things come together to be able to make things happen on the remote system. Now, for example, the command module. And if anybody else is a space geek, I really try hard to come up with some kind of NASA command module meme or pun here. I just can't do it. But I love that this is the command module, and the Apollo program had a command module. That's always what I think about. So Ansible built-in command. This is an example of one, the documentation for Ansible is absolutely fantastic. And also how easy it is to understand what you're going to be doing with this module, and also what its capabilities are, as well as what are the return values. What are you getting out, and what do you get to know back out of the system when you're running these operations? Some more documentation down here shows you the parameters. This is all the input. So you can easily get access to what are the defaults, what are my choices, how are these different behaviors going to impact how the command module, which is going to run a bash or a terminal command on the remote system, works. Some of the examples, if you want to cat the message of the day, you can see the first example here is going to be using ansible.builtin.command. This is telling the module of the command module to perform a command, cat etc motd, and we're going to register the output of this command with the register command. And what that does is it takes the standard out of the command being run and registers it into a variable that we can print and debug later, or even use and operate on later, like we're doing potentially in some of these other further examples. So this command is the module. This first name item is a task. This whole file could be its own task, and it could be a part of a larger playbook. As some of the other examples, run the command if a path doesn't exist. You can run a command if the path does not exist with args, and you can create arguments and pass arguments into your modules. There is an incredible amount of customization. And to jump into exactly what a very basic Ansible playbook would look something like this if we were to open it up in our editor. So you have three different files here that make up a playbook. We have our inventory file at the top, we have a playbook in the middle, and we have a task at the bottom. And we're going to start with the top file being the inventory file. This is where we're setting our default SSH host IP. And we're then grouping it in a group called a group called Vagrant. And then we're assigning variables to that inventory group. This is just a very small example of how you can pass in variables In this case, such as the user that we want to operate as the system user on the remote machine, all in different places, specifically in this case from the inventory. The middle file is our playbook file. This is our playbook YAML. It tells, in this case, this is going to be operating against a vagrant host, what hosts we're going to run the following rules on. So our host declaration is going to be vagrant, which matches line 3 of the top inventory file. And the roles on line 5 in the middle file here, the roles are going to be operated on in the roles folder off the parent of this directory path. Here we could have used our system variable if we wanted. It would have had the same effect. The bottom file is our task. It's our main.yaml, and this will install our Vim package from our Vim role, and we're using the apt module, and we're telling it to ensure the Vim package is present. You'll also notice that on line 4, I'm just saying apt. There are multiple ways of addressing Ansible commands. The newer syntax is what we saw before on the command module documentation. It's the Ansible base. This apt is a shortcut, which will eventually stop working in future versions of Ansible. You'll also note that in the bottom file here, I am mixing and matching YAML with settings.ini format. This is just to kind of show you that it will work. I don't recommend it. I recommend very heavily investing full bore into YAML. Even if you hate it, everything in Ansible is so YAML dependent. It will really save you in the long run if you're going to stick with Ansible to embrace YAML. So the task works to look at the apt module and passes in the package name of Vim, state is present. This will ensure the package is going to be installed. Now, earlier I said that one of the design features of Ansible was idempotence and being able to run this playbook over and over and over. The first time we run this playbook, it's going to install the Vim package, and then we can run the package, or we can run the playbook again, and we'll also see the same thing happen, but it won't actually take any action. So running this playbook from the command line, we'll use the Ansible playbook, which is what we got from the pip install. We pass in vagrant.yaml, which is our playbook file. And then at the command line, we're passing in an inventory file with a -i flag. So we're going to see that Ansible ran the play configure vagrant. It did our setup task and it did our install Vim tasks. Both options are green in the output, which means nothing was changed because the package was already installed. Now we can run this over and over, and it will take about the same amount of time because it doesn't have to do anything. The Ansible modules try their best not to do any work if they don't have to. That's why Ansible is essentially describing a desired state. So you're going to describe the desired state of your remote systems and your playbooks and your tasks, and you're going to break them down into the modules and the different components to make your life easier to understand how they all work together. And then you're going to run them through the command line or through another process I'll show you later through Ansible Tower or AWX. So Ansible variable precedence is a deep and dark rabbit hole you can go down. Here be dragons, to borrow something from Ed said in his earlier talk. Here be some dragons. You will get yourself into trouble with Ansible variable precedence because everybody does. This actual list to explain how the precedence works is about 5 times longer than these 3. These 3 are where I recommend new users start, because this is the most obvious and first places you'll start placing variables, and you can start overriding and start trying to clean up your playbooks. But remember YAGNI, you aren't going to need it. You may not always need everything, but the point of infrastructure as code is that you are describing everything about your infrastructure as much as you prefer to in your Ansible playbooks and supporting libraries. So a lot of times that this precedence is important is because you're going to need to be able to identify where a variable is and how it may be modified during the process of your run. I typically keep variables scoped to an environment. So I'll have environments, and then I'll have a production staging, maybe a test environment, and we scope everything down to where those variables can be completely different, and we can roll passwords whenever we want with minimal effort. So you can also reuse other playbooks. Earlier, we talked about Jeff Gerling, and I'm going to show you his author page here on Ansible Galaxy. Ansible Galaxy is kind of like Composer for Ansible, where you can go and install packages or playbooks and roles that other people have developed, and then you just apply your variables to the roles, and they will become your own working versions. And you can do that relatively easily. So Jeff Gerling, has tons of playbooks. He maintains all kinds of playbooks and roles around K8s, Docker, and specifically lots of Drupal projects, Raspberry Pi projects, and just different PHP servers and types of servers. He supports Red Hat on some systems, and they also support Ubuntu. So that just goes to show you how flexible your playbooks can be. If you're running a multi-OS cloud, you can still run Ansible. Ansible is not going to care. You can still build things in that kind of way to where they'll be flexible and overridable. So how you do that is essentially the same way you would with something like Composer, where except you just use the Ansible Galaxy CLI. You can install the roles, and they'll be installed to your system. You can override variables by adding a top-level variables folder, and this will be where the variables kind of propagate from. So you can see here, and we're in our role for the main. Sorry, to configure Vagrant, what we're doing is we're actually passing in a vars file. So we're doing vars main, and this is just, we'll override any other variables that are further down. So any variables we had set in install vim or our Gerling-guy.php role will be able to leverage those variables as well. You can see here, we're gonna override some of the PHP INI settings that are getting set on our configuration. And then we can add the role to our playbook by just shoving it in your playbook. Now, I don't really recommend this. This is kind of one of those things where it's a bad idea. TM trademark. It's okay if you have to, but just like you wouldn't version control PHP dependencies, you really don't want to version control your playbook dependencies unless you are heavily modifying them and then relicensing them, that sort of thing. So we can see that we're just configuring this in, and once we have it added to our roles folder, we can reference it just like we would normally without having to use the Ansible Galaxy syntax to show how to do that. Running this playbook, we'll see that it's going to be installing Vim, and then it's going to jump to Gerling Guy's PHP task or role, and then we'll see in the task, you can see the roles and the names of all the tasks are defined, so it makes debugging a little bit easier. So here's what would a production inventory look like? Let's say that we have 3 web servers, we have a load balancer, we have a database server, and we have a Redis server. And this is the LAMP stack that our application is going to be deployed into production. So we're going to group our web servers together so we can target web servers and with actions and tasks. We're going to do the same thing for our load balancer because we don't want to run our application code on our load balancer. We want to configure our load balancer there. Same thing for our database. We want to use that to scope out and run our playbooks to build our databases, our database servers, or run migrations, whatever we need to do on those systems. We can do the same thing with staging inventory. So this is pretty much how I build out my different environments. Don't worry, all of these IPs are free on the internet. Please have fun hacking these IPs. I welcome the challenge. And then one last, we have a dev inventory just to kind of give you an idea of how you can use this. Feel free to steal this or just avoid using this. What I'm doing here and the reason I'm passing the Ansible host here is I like to be explicit in my Ansible hosts because DNS is always secondary to me in my playbooks. The IPs will always be there. DNS is a human-centric feature, so we actually don't automate our DNS and our public IPs just yet. That's just a personal preference. I would much rather have a tighter control over that than having that automated just yet. Totally personal preference. Now, how do you pass these different playbooks into the environment? You can just pass in the prod INI, staging INI, dev INI, and it will use that inventory file for the playbooks. So this is how you can reuse playbooks in different environments really easily without having to rewrite your playbooks. Ansible can also deploy your code. This is a task using the Git module that takes in a repo, which is a GitHub SSH URL, a destination where the application is going to live, a version of the branch that we want to check out. We're setting some SSH options here where we accept the host key automatically. We specify where our SSH key is that we want to authenticate with. And we also want to turn off strict host key checking. We're also doing two other things because our application runs as a non-root user. And by default, we're using root for our Ansible remote user. We want to become another user, the actual application user in this case. So we say become true, and then we specify which user to become. And that's who Ansible will use as the system user to update this Git repository. That way we don't have root overriding, doing a Git pull. Some general Ansible advice: use environment-based playbooks and inventory files. Try to keep environment data localized to your inventory as much as you can. Sometimes it bleeds over here or there. Use Python or some other environment variable system for managing your secrets. Ansible supports throwing secrets in many different places. There's also Ansible secrets where you can lock down your Ansible password or your passwords or any plain text credentials that you may have. You can lock those down in hashed secrets for better security as you deploy these across your infrastructure. Also, couple your variables to your most focused point and then raise the scope as you need. What this means is follow kind of like the dry principle or the principle of copying, pasting code. Once is fine, twice is maybe okay, and then the third time you refactor, right? Think about that as you're thinking about your Ansible variables as well, and that will give you a little bit better idea on where a variable should go if you're not sure. Now, Ansible Tower is the greatest, it's like the icing on the cake if you're using Ansible and if you're in the Red Hat ecosystem. Automation Controller is essentially a lot of glue and syntactic sugar and a lot of custom development that Red Hat has wrapped around Ansible Tower or Ansible AWX. It is a standalone platform that serves as your Ansible control node, where all of your playbooks are run from and all of your tasks and everything is centralized into a remote system. So you don't have to have developers running these playbooks from their own systems. This also helps from a security standpoint to where you can restrict some playbooks to only being able to be run from AWX and not other places. The standard enterprise pricing, as you could probably imagine, applies here. If you have to call for pricing, you probably can't afford it. If you're already in Red Hat's world, this is a fantastic solution. If you are not in Ansible's world, or sorry, Red Hat's world, I offer you the open source Tower version called AWX. The AWX project is what Tower was built off of. So where AWX isn't all of the syntactic sugar and it's technically not quote unquote production ready. I've been using it for 2 years on the day job and it has been rock solid. Your mileage may vary. I'm very particular in how I write my playbooks and how we operate our infrastructure. So maybe that has some of the lends itself to some of the stability we've seen in it, but we've had really good luck with just running AWX on our own. And what this looks like is we create templates and we map templates to playbooks. And then we can have projects, which are groups of playbooks. We can have organizations, teams, repositories, and we can go through and be as detailed and use AWX to actually create customized dynamic versions of our playbooks by overriding variables. Now, this is where I get to have a little fun and show the PHP developers how to do a Python virtual environment. And I'm going to go through this really quick because I am probably running a little short on time, and it's not super important unless you're really going to jump into Python. But Python versions are essentially system level versions. So typically Python, instead of composer install using the system PHP, think about installing a PHP into your project, and that's what Python virtual environments are. So we're going to run Python and create a virtual environment, and then we're going to run Python again and see that it's the old version. Then we're going to activate the environment and see that we're using the new version. If you don't ever plan on looking at Ansible, that's no big deal. But that's how we can pip install Ansible. But make sure you don't do what I did and typo it at the top. You actually have to spell it correctly to get it. And you'll get Ansible. And this is what Python package management looks like. Looks kind of like composer install. You can also freeze your dependencies. We don't have composer.lock in Python, so you just kind of have to say freeze. This is what you would do if you were building your own playbooks and you wanted to run Ansible from a repo. This is kind of the process you would follow. Let's build a deploy playbook, and I'm going to fly through this as well. We have this application that lives at this URL. Feel free to check it out. It checks vagrant data on box downloads. So what we do is to download or to deploy this application, we have Slack tokens, we have our Git repo, our branch, our app URL, and all of this other information we have, and we are overriding all of the variables. So we're specifying our home, our username, and even a password. Don't do this. Don't put plain text passwords. Use Ansible secrets. I didn't cover that here because it is kind of an in-depth topic. We can deploy our role, and we can actually send a notification to Slack and say, hey, we're starting a deployment. And then we can run commands. Then we can send a notification to Slack and saying, hey, it started, we're done. Also, Ansible supports templates. This is how you can place configuration files on a remote system with variable data. So to create our environment file for this application, I can pass in the database credentials and any other information like the app URL, and the app key would probably be something you'd want to store in those as well. And you use the template module and you pass in a source file, and then you pass in destination. And then if you use backup, you'll always have a backup file before Ansible places the new one. Highly recommend that when you're doing this for environments, especially secret, so you can kind of track a history on the file system. You can also update the repository, very similar to what we saw a few minutes ago. We can install Composer. There is a Composer module, and you can also use the when keyword. So here we're using Composer install, but we're not going to use with the dev dependencies when we're in production, but we do want dev dependencies we're in staging or in development. So you can use all kinds of conditionals to vary what commands you're running or what module you're running. Similar for the, we can run migrations, and then we can put our application back live if we have to take it offline. And now the job's done. We can say, hey, everything's done. We're all fine here. You can also break down your Ansible playbooks. I highly recommend breaking up tasks into smaller groups, like installing PHP, setting up a Git repo, updating your firewall, or adding any firewall rules or such. Also, you could do system maintenance. You could target the inventory groups to do system maintenance only on specific systems. And you can also only run updates for apt if the cache is more than a specific time ago. That way you're not wasting runtime during your playbooks to actually do things like apt update when you don't really need to. You can also install and configure Certbot. You can create cron jobs that will automatically renew your Certbot certificates, which is also handy. And if you need to do something like HAProxy, where you have to combine the certificates in a specific format, you can do that as well. You can just create a job to cat files together and put them where you expect them to be. And then you can also do delayed restarting by using handlers. That way, if you have a system that you're configuring and you need it to restart Apache, and then you're doing several other things that also need to restart Apache, you only need to tell it to handle the Apache restart once, and Ansible will figure out at the end of the run, if it hasn't restarted Apache yet, then it will do it when it runs all of its handlers. You can also add renewal hooks, which is just a way of interacting with Let's Encrypt to do the renewal. Let's see, we can also install Docker, and just a lot of these are examples of going through and showing you how the modules work. What we're doing here, we're actually pulling a Docker image as well, and then we're going to prune the Docker system so we can reclaim some of that hard drive space. We can add users. Here we're adding Luke, Leia, and Yoda. Looping over arrays, you can also get pretty involved, and you can create arrays of data or hashes and loop over them. Keep your secret secret. There is a fantastic article at this URL that was written that was written actually this year that is really good about keeping your secret safe in Ansible. I highly recommend checking it out and using it. You can also roll your updates to where updates will be faster if you have groups. So you can group your hosts together and run the updates. You can also have maximum failure, where you can have a failure tolerance. So if something is flaky and you can sustain a default tolerance of a few systems, you can actually set that. The directory layout documentation is all in the Ansible docs. Highly recommend this. This will show you how and where to put files and to where they will continue to make sense and you won't confuse yourself, because you'll eventually get lost in all of the Ansible stuff. Thanks. I'm going to check for Q&A. If anybody has any questions, feel free to ask questions in Slack. I'm not sure how I am on time.